We have the technology to get to asteroids now.
Yeah.
So what we now need to do is work out extraction techniques for resources on those asteroids. So once we have the technology, that's what we're developing at the Asteroid Mining Corporation. When we have that technology, we're essentially looking at expanding the global economy out beyond Earth orbit and into the asteroid belt to start looking at asteroid mining as a new industry for the United Kingdom.
Imagine untold wealth floating silently through the void. Asteroids rich in platinum, gold, nickel, rare earth elements, and materials that could power humanity's expansion into space. Scientists, engineers, and private companies are racing to tap into these celestial treasure troves, but the stakes are far higher than profit alone.
Long frozen billions of years ago, but that ancient magnetic field that it could have generated could be imprinted in the surface layers of Psyche, which cooled in the presence of this field. And so they would have what we call
How will asteroid mining reshape global economics, geopolitics, and life on Earth? Which nations and corporations will gain the first foothold in this new frontier? And what rules govern a resource no human has ever claimed before? Could the next industrial revolution occur not on Earth, but in the cold expanse of space? Every mission, every launch, every data point could rewrite the future of humanity. Hit subscribe now. Missing even a single development could mean being left behind in the era of space resources. The promise of asteroid resources. Asteroids are more than rocky debris. Some are literally floating vaults of rare metals, containing billions of dollars worth of platinum group metals, cobalt, nickel, and even water ice. Water in space isn't just a resource, it's fuel. Hydrogen and oxygen extracted from ice could power spacecraft, satellites, and lunar bases, reducing the need to launch everything from Earth. Metals harvested from asteroids could supply the electronics, batteries, and infrastructure that drive our civilization, making space mining not just a futuristic dream, but an economic necessity. The potential of asteroid mining is staggering. A single asteroid, only a few hundred meters across, could contain more platinum than has ever been mined in human history. Beyond wealth, it could transform global supply chains, reducing dependency on politically unstable regions on Earth. Corporations and governments alike are investing heavily in scouting, mapping, and technological research to access these untapped resources. Upcoming missions, humanity's first steps. Several upcoming missions aim to take the first concrete steps toward asteroid mining. NASA's Psyche mission, scheduled to reach the metal-rich asteroid Psyche, will explore its composition and internal structure, providing critical data for future mining technologies. Meanwhile, Japan's Hayabusa 2 has already returned samples from Ryugu, revealing organic compounds and clues about the building blocks of life. Private companies are not far behind. Firms like Planetary Resources and Deep Space Industries are developing spacecraft capable of capturing small asteroids, extracting water, and returning high-value metals. These missions face immense technical challenges, from microgravity extraction and remote robotics to processing materials in space. But the potential rewards make the risks worthwhile. Economics of space mining. The economics of asteroid mining are complex. Launch costs remain high, but reusable rockets, like SpaceX's Falcon 9, are reducing the financial barrier. A single successful mission could generate billions in materials, but investors must consider time, technology, and regulatory hurdles. Mining asteroids could disrupt commodity markets on Earth, potentially flooding markets with platinum or other metals, impacting prices globally. Water and fuel extraction in orbit could create a space-based economy, enabling lunar bases, Mars missions, and deep space exploration. Advanced AI ensures precision, efficiency, and safety, while monitoring for anomalies or potential failures. These technologies are being tested on Earth and in low Earth orbit, with full-scale operations expected in the next decade. Before we continue, hit subscribe, because the next sections will explore global competition, geopolitical stakes, and the real-world impacts asteroid mining could have on economies and societies here on Earth. Missing updates could mean missing critical insights into humanity's next industrial revolution. Global competition and strategic interests. Asteroid mining isn't just about money, it's about strategic advantage. Countries investing in space resource infrastructure gain leverage over Earth-based supply chains. Nations controlling high-value asteroids could dominate critical metals, fuel production, and satellite manufacturing. China, the United States, Japan, and several European nations are all developing policies and missions targeting space resources. Competition could lead to international disputes, new treaties, or even unanticipated conflicts if claims overlap. The next era of geopolitical strategy might extend beyond Earth, with space becoming the ultimate frontier for power, influence, and survival. Potential impacts on Earth. The extraction of asteroid resources could reshape industries on Earth. Metals once scarce or controlled by a few nations could become abundant, reducing dependence on terrestrial mining and the environmental damage it causes. Water-derived fuel in space could make deep space missions feasible, opening opportunities for scientific exploration, tourism, and colonization. However, sudden influxes of rare metals could disrupt global markets, destabilize economies, and challenge existing industries. Policymakers must balance innovation, profit, and sustainability to ensure that humanity benefits collectively from space resources, rather than enriching only a few. Scientific opportunities beyond economics. Asteroid mining missions are not purely economic. They offer unprecedented scientific opportunities. Studying asteroids reveals the history of the solar system, clues about the origins of water and organic compounds, and insights into planetary formation. Every sample, every sensor reading, and every mining test adds to humanity's understanding of our cosmic neighborhood. Advanced mining technologies, turning dreams into reality. Mining asteroids is not science fiction. It is the next frontier of engineering. Robotic spacecraft must navigate microgravity environments where traditional mining methods fail. Innovations such as autonomous drones, precision drilling rigs, and material separation systems.
This is my first opportunity to actually be involved with that process of designing the investigation and figuring out how to clean up that data so it will be usable by the science community at large.
Are under development. These machines can identify metals, water ice, and volatiles, separate valuable materials, and store them safely for transport to orbiting processing facilities. AI is central to these operations. In real time, AI monitors extraction, compensates for unexpected shifts in microgravity, predicts structural integrity of asteroids, and prevents catastrophic failures. This intelligence allows spacecraft to operate millions of kilometers away from Earth with minimal human intervention. In situ resource utilization, the game changer. One of the most promising concepts is in situ resource utilization, ISRU. Instead of transporting raw asteroid materials back to Earth, ISRU focuses on using these resources directly in space. Metals can be converted into components for satellites or spacecraft. Water can become rocket fuel, providing energy for deep space missions without returning to Earth's gravity well. This approach drastically reduces costs and accelerates humanity's expansion into the solar system. Some companies are exploring orbital factories, facilities where asteroid metals are processed and assembled into spacecraft or station modules entirely in microgravity. This transforms asteroids from distant targets into raw material suppliers, fueling a self-sustaining space economy. Upcoming missions, humanity's first operational steps. Several upcoming missions are poised to push asteroid mining from theory into reality. NASA's Psyche mission aims to explore a metal-rich asteroid in unprecedented detail, offering insights into internal composition, density, and potential extraction feasibility. Japan's Hayabusa 2 has already returned samples, proving sample return missions are possible and can provide critical scientific and economic data. Private initiatives are now entering operational testing. Companies like Planetary Resources and Deep Space Industries plan to capture small asteroids, extract water and metals, and test in-space processing. The Ares spacecraft concept involves capturing an asteroid and redirecting it into Earth orbit or lunar orbit for processing. These missions are proving the concept is achievable. The technological and financial feasibility is becoming real. Economic impacts. The new space economy. Asteroid mining has the potential to disrupt global markets. Precious metals like platinum or rare earth elements, currently concentrated in a few regions on Earth, could become abundant in orbit. This would reduce scarcity, reshape commodity markets, and shift geopolitical power. Water and fuel from asteroids could eliminate the need to launch propellant from Earth, lowering costs for satellites, space stations, lunar missions, and even Mars expeditions. This could democratize space access, enabling smaller nations and private companies to participate in exploration and industry previously dominated by superpowers. However, there are challenges. Sudden abundance of metals may crash prices. Infrastructure costs are high and missions are risky. Investors must weigh long-term potential against immediate returns. Governments may also impose regulations or taxes on space resources, affecting profitability and global access. Geopolitical stakes. The race beyond Earth. The race for asteroid resources is no longer theoretical. Nations and corporations are vying for strategic positions. The United States, China, Japan, the European Union, and private corporations are developing capabilities to map, extract, and process these resources. Control of key asteroids could equate to control over essential metals and fuel, giving a nation or company unprecedented leverage in both space and terrestrial markets. Policies, treaties, and regulations are emerging. The Outer Space Treaty forbids national sovereignty over celestial bodies, but is vague about resource extraction.